A modern megaproject is a highly fragile network of dependencies. When a single element falls behind, the connected nodes cascade into a systemic failure. The operational vulnerability lies in latency. Traditional scheduling requires manual updates, creating a dangerous time gap between the moment a physical delay occurs on the ground and the moment management actually sees it. Project managers rely on massive files containing over 5,000 individual line items. This sheer volume of data acts as a smokescreen, easily hiding cascading delays from the naked eye. The executive dilemma is a matter of timing. Leadership often discovers a severe operational bottleneck only after it has already bled into the capital return on investment. Theta AI resolves this by deploying a predictive intelligence platform designed specifically to eliminate reporting latency entirely. The system instantly bridges the gap between granular, raw timeline data at the site level and immediate executive foresight in the boardroom. To understand how this works, we have to follow the exact operational sequence, from the initial data ingestion through predictive modeling and up to high-level strategic alignment. Reducing the gap between site-level delays and executive response directly limits the window of exposure for project capital. The workflow begins simply by securely dragging and dropping a raw schedule file into the platform. The system immediately initiates an automated parsing phase, replacing the manual data entry that typically slows down reporting cycles. Before any analysis happens, it runs an immediate integrity check, returning a timeline data processing errors flag if there are structural issues within the file itself. Once cleared, it generates a complete suite of baseline reports instantly. This process requires zero manual input from a project manager. The scale of this ingestion is massive. Over 5,000 individual operational activities are parsed and analyzed simultaneously. This dynamic S-curve chart plots cumulative progress against time to establish the project's trajectory. By comparing actual progress against the late and early plans, it calculates exact variances by filling the shaded area between the trend lines. Automating these baseline analytics recaptures critical operational time for the team, eliminating days previously lost to manual report generation. With the baseline set, Theta AI activates an intelligence advisor powered by the Claude 4.6 framework. This engine continuously analyzes the critical path, tracking the precise interwoven dependencies of every predecessor and successor in the file. To test this logic, an executive can query the system with a custom what-if scenario. For example, testing the exact impact if a primary FG compressor is delayed by 2 weeks. This diagram illustrates the AI mapping the impact of that delay onto the compressor node. The mapped dependencies force a mathematical shift, updating the entire branching web down the timeline. This recalculates into a month-by-month slippage report, projecting time lost over 4 months. The AI evaluates this projection and separates activities requiring immediate executive escalation from the tasks that can still be optimized on the ground. It pinpoints precise points of friction using a staircase bottleneck analysis, revealing exactly where downstream tasks are taking unnecessarily long. This ability to calculate the ripple effect of a single delay allows the schedule to identify and neutralize risks before they compound. Extracting actionable intelligence requires rapidly filtering out the immense, confusing noise inherent in a massive, multi-thousand-line project file. By cross-referencing timeline inconsistencies against the critical path logic, the platform separates minor anomalies from structural schedule threats, reducing alert fatigue. For vulnerabilities that have not yet triggered a delay, the platform compiles a blind spot register, highlighting unseen structural risks before they become active problems. When delays do materialize, the system pivots to strategic project recovery, providing visual models to manage unavoidable setbacks. This recovery waterfall chart plots quantitative schedule variances across different operational streams to serve as a visual triage tool. By isolating the exact operational stream's bleeding time, the waterfall calculates the precise numerical gap needed to return the project to its baseline target. This calculation yields a singular, definitive headline regarding the new completion target based on the current rate of recovery. Access to this level of advanced telemetry allows leadership to surgically recover an off-track project, rather than relying on reactive, blanket acceleration mandates that drain capital. Granular data is only valuable if it drives rapid, confident decision-making at the highest levels of leadership. To achieve this, the Intelligence Hub aggregates the entire project appraisal and distills it into a plain text executive summary. This performance telemetry wave chart tracks overall project health, scoring exactly what operational areas are succeeding and what is failing against numerical benchmarks. Executives can monitor the interactive risk register, clicking on any specific flag delay to instantly drill down into the underlying data. Every risk generates a trifold output, analyzing the future consequences, offering specific strategic recommendations, explicitly listing what not to do. This constellation command map visualizes macro-level strategic alignments, presenting complex organizational dependencies as interconnected hubs. Synthesizing this overwhelming complexity into clear, binary, and actionable choices is the true foundation of effective executive control. Top-down telemetry relies on accurate bottom-up field data to remain relevant. Ground teams use a connected mobile application to input qualitative feedback, explaining exactly why a flag delay is occurring in real time. These updates flow directly into Theta Engage, which serves as a centralized communication hub for the entire project team. When a meaningful update hits the timeline file, the system automatically triggers a post to immediately inform all relevant stakeholders. Users can review, summarize, forward, like, and comment directly on these posts, creating a continuous engagement loop around critical updates. All related documentation is tied together in an overarching knowledge base, connecting every project file into a single accessible source of truth. Integrating bottom-up field data with top-down predictive analytics ensures the project schedule remains an accurate, predictive representation of the work being done, protecting both efficiency and capital ROI.